Good morning, and today we are doing a new chapter in 10th class CBSE mathematics, that is coordinate geometry. This coordinate geometry is also called analytical geometry, and we deal with the coordinates of the points and also, of course, the figures formed by those points. And let us see that what can be done, of course, in this unit. And there are two or three important formulae, of course, in this chapter, of course, which we should remember to work out the problems in the exercises. And the first formula is about the distance formula. Okay, if there are 2 points given in a plane, generally referred to as a Cartesian plane, and we need to find out the distance between them given the coordinates. And there is another second formula, of course, which is interesting, is to determine a point which divides the given line segment in a specific ratio. And there are a few applications of the second formula, which is called section formula. So distance formula and section formula is what we need to do today in this coordinate geometry. Okay, fine. The topic today is coordinate geometry. And the first formula we are talking about here is the distance formula. This is generally the x-axis, and this is y-axis. And the plane which contains these two axes is called Cartesian plane. Okay, so we have two axes here, x-axis and y-axis, and they meet at the point origin. Okay, that is referred to as O. And as we move to the right side on the x-axis, we mark the points as positive one is this side, and this side it is negative, of course, on x-axis. And this is y-axis, and as you move above, the points are positive, and as you come down, the points are negative. And any point you have in the plane can be represented by two coordinates, x coordinate and y coordinate. And conversely, if you have a point whose coordinates are known, it can be assigned to a point in the plane. If the point is in the plane, it should have some coordinates. And if there are some coordinates, and it represents a point, of course, in the plane, vice versa. Fine. So now you write here 1, 2, 3, 4 and so on. This side minus 1, minus 2, minus 3 and so on. This side you write 1, 2, 3, 4, and this side you write minus 1, minus 2, minus 3 and so on, depending on the scale you are choosing. Not necessary that every time you should mark the points as all the integers. Like sometimes, like for every 1 centimeter we may take 5 units, 10 units, whatever it is. For the convenience sake, let us say we are writing 1, 2, 3, 4 and so on. Fine. Here now there are 2 points given in the plane whose coordinates are known. Okay, there are 2 coordinates given here. There is one point here, A. The coordinates are x1 and y1. X coordinate and y coordinate. There is another point B whose coordinates are x2 and y2. You can say x2 comma y2 and x1 comma y1. So there are 2 points given. If points are given to you without doing all this plotting and all that, you need to find out the distance between them. Okay, if there are 2 points given to you, x1 y1 and x2 y2 in the plane, our intention is to determine the distance between them. It is something like the length of this line segment you have to find out. For that, what I am doing is I draw perpendiculars onto x-axis. Let me say this is M, and I draw a perpendicular from B onto x-axis, and let the foot of the perpendicular be N. And also I draw a perpendicular from A to this BN. It is like this. and let me say this is P. So we drew perpendiculars from A and B onto the x-axis and we marked them as M and N, the feet of the perpendiculars drawn, and we also drew a perpendicular from A onto this BN, that is a P. Okay, and we have formed a right angle triangle as it's seen here. This is a right angle triangle. Okay, so you should understand actually how we reached this point A. From origin, I moved x1 along x-axis and I moved in this direction y1. So here OM is equal to x1 and AM is equal to y1 because it's a height. Similarly, how did we come to this point B? We said x2, y2 are the coordinates. ON is x2 and this BN is y2. So ON is equal to x2. I have come x2 units along x-axis and y2 units I moved along y-axis, of course. And what is that? Bn is equal to y2. So given the coordinates and the interpretation of how we reached those points, I want to know about this triangle. Okay, this is a right angle triangle. If I know AP and PB, and using them I can find out AB, because you know it's a right angle triangle, Pythagorean theorem can be applied. Now I go like this. I want AP. My AP is the same as MN. And if I want MN, ON minus OM. ON minus OM. I get my coordinates here. OM is x1 and ON is x2. ON is x2, OM is x1. So x2 minus x1. And thus I have found this AP. But now I want a PB. Okay, PB. Primarily this PB is BN minus PN. BN minus PN. BN I know I have it, of course, no problem for that. But PN is the same as AM. I write BN minus AM. And this tells me BN minus AM is Y2 minus Y1. Okay, so I have AP and I have PB. Using these two lengths, I can find out AB. And now I can apply my Pythagorean theorem. AB square is equal to AP square plus PB square. And this is triangle APB, right angled at P. Right angled. Okay, right angled at P. Now let us substitute the values known to us. AB square is equal to AP square. AP is x2 minus x1. So x2 minus x1 whole square and PB y2 minus y1 whole square. And therefore AB is equal to, I just say root over this one, x2 minus x1 whole square plus y2 minus y1 whole square. So there is a little, important observation, of course. X2 minus x1, no matter whether it's positive or negative, when you square it, it is all the time positive. Similarly, y2 minus y1, regardless of the fact whether that is negative or positive, when you square it, it is positive. And therefore, under the root, essentially, you have all the time a positive number. So it's a real number you are going to get. It can be imaginary because this is never a negative number. This is always positive. But when you find the square root can be positive or negative. That's the reason when you determine the square root, you write plus or minus. But because this is a distance, you can't take the negative root. You should take all the time only the positive root. And some people, to ascertain that, they just put like this mod. Means even if don't take the negative root, it is only the positive one. Okay, so inside the square root all the time we have a positive number. There's no question there, but only thing is when you find out the root, you can't write plus or minus something because there is distance. Distance is always positive. Okay, it can be negative distance and all that, like, and therefore we just write mod. Generally you can omit it also. It's not so important for you, but you should be pretty sure that the distance can be negative. This is how we find out the distance between 2 points. If a x1 y1 and b x2 y2 are any 2 points in the plane, the distance between a and b is given by root over x2 minus x1 whole square plus y2 minus y1 whole square. This is what we mean by the distance formula. We just do an example here. Say there is one point a at 2 comma 3 and there is another point, okay, at say 5 comma minus 6, and these two are the points given. You need to find out the distance between them. You just simply have to plug in these values here. AB is equal to root over x2 minus x1 5 minus 2 whole square plus y2 minus y1 minus 6 minus 3 whole square. So this 5 minus 2 is 3, 3 squared is 9, and minus 6 and minus 3 is minus 9, minus 9 squared is plus 81. So your answer is root over 90. That's it. So if you are given 2 points, you can determine the distance between them, and distance we take only the positive root, so you get a positive value. If the points are you consider are the same, okay, if you take the coordinates once again the same a and b, if they are not distinct points, naturally the distance between them is 0. Okay, if you take the same coordinates for both the points, the distance between them is 0. So there is no such case generally which comes like that where the distance becomes 0 between the points, like, okay, fine. And now in exercise 7.1 there are a few problems where you need to find out the distance between them. In some cases he is just asking prove that it is a rectangle, prove that it is a parallelogram, and so on. I just want to give you a small hint when you are proceeding like that. If you want to prove that it is, say, a rhombus, there are 4 vertices given to you, and if you want to find out that it is a rhombus, all the distances you will find out AB, BC, CD and DA. If all the distances are equal, it becomes a rhombus. But mind you, if diagonals are also equal, like AC and BD, then it becomes a square. So a rhombus becomes a square when the diagonals are equal. Okay, let us quickly understand how we have to take them like as what kind of figures you are going to get. A quick recap of what you learnt. This is a rhombus. All sides are equal, but all angles are not equal. But if each angle becomes 90 degrees, then you probably get a square. The difference between rhombus and a square is, in a rhombus all sides are equal. Okay, AB, BC, CD and AD are equal, whereas here not only the sides but the diagonals are also equal. Okay, even BD and AC are also equal. Then it becomes a square. The next one is, you have, let us say, a rectangle. Opposite sides are equal and diagonals are equal. Okay, you can say if this is ABCD, a rectangle, opposite sides AB and CD are equal. Similarly, BC and AD are equal. And this is not enough, of course. You should write something more. AC and BD also are equal. Diagonals are also equal. And then it becomes a rectangle like. But if you have a parallelogram, okay, only opposite sides are equal and not necessarily the diagonals are equal. If you have AB, is equal to CD, BC is equal to AD. That's it. So this diagonal and this diagonal, they may not be equal in a parallelogram. Okay, in a parallelogram, opposite sides are equal. Diagonals need not be equal. But in a rectangle, diagonals are also equal. In a square, all the four sides are equal and the diagonals are equal. But whereas in a rhombus, just all the four sides are equal. We don't talk about the diagonals. They may be equal or may not be, of course. So if you can understand this fundamental idea about the quadrilaterals you are talking about, and then of course we can start working out the problems. Let us see now. There are three questions here where you need to find out the distance between them, and that's an easy one. And find the distance between the points 0, 0 and 36, 15. Okay, can you now find the distance between the towns A and B discussed in 7.2? Fine. We move like this. Okay, and this is my first problem. And he has given that there are 2 points 0, 0, and there is another point 36, 15. Okay, this point let us say is P, this point let us say it's Q. You need to determine the distance between P and Q. This is a very simple proposition. So PQ is equal to under root 36 minus 0 whole square, and again 15 minus 0 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. Here you have 36 squared, okay, it's 1296. And here you have 15 minus 0 is 15 only, 15 squared, 225. And if I add these two numbers here, see 5 plus 6 is 11, 1, 1, 1 plus 2, 3, 3 plus 9 is 12, 2, 1, 1 into 3, 3 and this one of course, 15, 21. This is what we have got. And I just check, of course, to find the square root of this one. I will find that this is the square root of 1521 is the square of 39. So my answer is 39. I need to find out the square root of this 1521. Let us quickly recall the method we use. 1521. Okay, and you just can, of course, 15. The 40 is a 1600, and just guess somewhere there you can write that 39 is the square root. And the next one, of course, the question is an interesting question. Okay, and I just take off my quadrilaterals. This is a simple problem, but however, just have a look at it. There are 3 points given to you. This is 1, 5. And this is 2, 3 and minus 2, minus 11. Okay, let us say that these 3 points are P, Q and R. Okay, there are 3 points given to you. You need to prove that these 3 points are collinear. Okay, and anyway, it's not given that they're collinear. You have to check whether they're collinear or not. So let us understand, if these 3 points lie on a line, we don't know which point is between what or whatever it is, like, you know. If this is the condition, let us say PQR, we say the points are collinear. They belong to the same line. Okay, if they belong to the same line, something interesting is happening here. PQ and QR, if you add, it is as much as PR. PQ plus QR is equal to PR. And therefore, what method I follow here is, I find out the distance between PQ, distance between QR, and the distance between PR. And I just check if any sum of any 2 of them is equal to the third one. And if I can prove that, that's it. I can say they are collinear. Okay, so to prove the collinearity using the distance formula, that you should remember. In the later classes, you can prove that the points are collinear in a number of methods, not less than 10 methods. But at present, we are using the distance formula. I want to find out the distance between PQ. So I take x1, y1 and this says x2, y2. So my distance between P and Q is 2 minus 1 whole square and 3 minus 5 whole square. So 2 minus 1 is 1, 1 squared is 1, 3 minus 5 is minus 2, and minus 2 squared is 4. And my answer is root 5. I got one distance. Okay, I go to find the distance between Q and R. Q and R. And similarly, I take up P and R later. So I need to get this distance QR. So this is x1, y1 and this is x2, y2. Because we want the distance between these 2 points actually. Root over minus 2 whole square plus minus 11 minus 3 whole square. Minus 11 minus 3 whole square. And how do we simplify this one? This is minus 4 squared 16 and this is minus 14. Minus 14 squared is 196. And now this is 212. Just leave it like this for the time being. Don't bother much about it. Let us go for this distance PR. Okay, PR is equal to. So this is x1, y1 and this is x2, y2. Minus 2 minus 1 whole square root over minus 2 minus 1 whole square plus minus 11 minus 5 whole square. Minus 11 minus 5 whole square. And on simplification, this is minus 3 squared, 9, and minus 16 squared plus 256. And this I will have 265. I don't know, like, if this is not giving me, see, if I square this one, 5. If I square this one, 212. If I square this one, 265. But it's not matching that 5 and 212. If I add up, it won't give me this 265. And therefore, P, because this is the longest side, remember that. PQ plus QR is not same as PR. Okay, so PQ plus QR is not equal to, of course, is not equal to PR. Sum of these two distances is not same as this distance PR, and therefore these 3 points, they are not collinear. Okay, so if 3 points are collinear or not, if you want to determine, what is that we are doing? We find out PQ, QR and PR, and sum of any 2 of them, if it's the same as the third one, then you can say the points are collinear. Because like if 3 points have to give you a triangle, there is a condition that sum of 2 sides must be greater than the third side. So if sum of 2 sides is same as the third side, that tells that the points are collinear. No triangle is formed, the points are lying on the same line. But in this particular case, the distances we have found, they don't form collinear points actually. Okay, and with that, of course, we move to the next problem. And he has given 4 points, and what kind of quadrilateral you are expecting actually from them. So I take this is 6th question, first bit, and I take the 4 points given to me, minus 1, minus 2 and 1 comma 0 and minus 1 comma 2, and last one is minus 3 comma 0. There are 4 points given to you. Obviously these 4 points can form a quadrilateral, and the question given here is that what's the nature of the quadrilateral you have formed? I repeat, there are 4 vertices given to you, and you can plot them and find out what kind of figure you are going to get. Okay, intuitively you can do that, but instead here you have to use coordinate geometry principles, and therefore I find out the distance between every 2 points, AB, BC, CD and DA. Okay, I'll just check if that can give me something, some idea about the nature of the quadrilateral that is formed. So first I label the points, okay, B, and this is C and this is D, and my intention is to find out distance AB and root over, come on, 1 minus minus 1, 1 minus minus 1 whole square, and plus 0 minus minus 2 whole square, 0 minus minus 2 whole square. And what am I going to get here? This is 2. Minus of minus 1 is plus 1. 2 squared is 4. And this is plus 2. Plus 2 squared is 4. And my answer is root 8. So leave it there for the time being. We go to find out BC. BC is equal to under root, come on, minus 1 whole square, BC we are trying to find out, and 2 minus 0 whole square, 2 minus 0 whole square. Exactly the same we are getting, that this minus 2 squared is 4 and 2 squared also is 4. My answer is again root over 8. So AB and BC, but these are adjacent sides of the quadrilateral, are not giving me anything immediately. So let me go for CD also, like CD is equal to under root. These 2 points we are taking, minus 1 minus of minus 1, minus 3 minus of minus 1 whole square, and the next one is 0 minus 2 whole square. And good heavens, we are getting again, this is minus 3 plus 1, minus 2 squared, 4. And this is also minus 2 squared is 4. Again, it is root 8. So DA is the last side we are trying to find out. And A and D you should take. Minus 3 minus of minus 1. Minus 3 minus of minus 1 squared. And next one is 0 minus minus 2. 0 minus minus 2 squared, and minus 3 plus 1 minus 2 squared is plus 4, and minus of minus 2 plus 2 squared is also 4, and this is root 8. So something interesting you have found is that all the 4 sides are equal, the same root 8 you got. But so this can be a rhombus, but can I move ahead to check if that can be a square? So if this has to be a square, given all the 4 sides are equal, I should check the diagonals. So I just go to find out AC now and BD. AC is, I should take this point and this point. Minus 1 minus of minus 1. Minus 1 minus of minus 1 squared plus 2 minus minus 2. Okay, 2 minus minus 2 squared and root over that. So this is minus 1 plus 1, 0, squared is 0, and this will be plus 4 squared is 16, and here I have root 16 is 4. So this is my diagonal, and I try to find out another diagonal BD. So this and this I must take, minus 3 minus 1 whole square and 0 minus 0 whole squared, and the answer is again 4. This is minus 4 squared and square root 4. This is anyway 0. So what I have got is AB, BC, CD, DA are equal, and each of them is root 8, and both the diagonals are equal, AC and BD, they are 4 each, and therefore ABCD is a square. All sides are equal and the diagonals are also equal. So my conclusion is that all the 4 sides are equal here, and as the diagonals are also equal, and therefore the given figure is a square. Okay, and there is another question. Find the point on x-axis which is equidistant from 2 points. Okay, let us do this problem. And I try to draw roughly what exactly he is asking. This is 7th problem. And see, this is x-axis, this is y-axis, and there are 2 points given to you, 2 comma minus 5, 2 comma minus 5. Somewhere here you have 2 comma minus 5. Let us say this is P. 2 comma minus 5, and another point is minus 2 comma 9. Minus 2 comma 9. Somewhere here you have minus 2 comma 9. Okay, let us say this point is Q. And he is asking, there is a point on x-axis where this distance is the same as this distance, something like that. There is a point on x-axis, let us say you need to find out that A in such a way that this distance and this distance are same. Okay, some rough figure is drawn. So what is that you should do is that you have to find out the coordinates of that point A. Where is A? He has given that it is on x-axis. Any point on x-axis, the y coordinate is 0. So let AB, okay, coordinates of AB, okay, and any point on x-axis, y coordinate must be 0. So I said some A comma 0. You can say at. Let A be at A comma 0. A comma 0 is the address of a point. A is the name of the point. Therefore, you can never put is equal to between them. Capital A is the name of the point. A comma 0 is the set of coordinates, like x is a pair, ordered pair. So don't put is equal to between them. A name and address, they can be equal. Okay, fine. Anyway, I have to yes. So we are given that AP and AQ are same. I want to find out the distance between A and P. Come on, A minus 2 whole square plus 0 minus minus 5 whole square. 0 minus minus 5 whole square. Root over that. This is AP. How do you find AP is equal to AQ? Sorry, I write AQ. So now, how do you find out AQ? Because you know that this A is at A comma 0. Come on, A minus minus 2 whole square. A minus minus 2 whole square and plus 0 minus 9 whole square. Let us start working actually. And you can remove square root on both the sides, because squaring on both sides you can get A minus 2 whole square. This is plus 5 square. Plus 5 square is 25 is equal to A plus 2 whole square. A plus 2 whole square plus minus 9 square is 81. My next step will be, I expand this one, A square minus 2 into A into 2, 4A, A minus B whole square formula, plus 2 square is 4. I have a 25 here is equal to, how do you expand A plus B whole square? A square, 2 into A into 2, 4A, 2 square is 4, plus 81. I can eliminate that A square and A square, and minus this 4A comes to this side, because is equal to is here, comes to this side, becomes minus 4A. That 4A is coming this side as another 4A. Come on now, 81 plus 4 is 85. This 25 plus 4, 29 will go to that side, minus 29. And if you can work out, this is minus 8A. And 15 minus 9 is a 6. There's 7. 7 minus 2 is 5. That's it. Hence, A is equal to, this minus can be taken to that side, minus 56 by 8 and minus 7. And therefore, where do you have that point on x-axis? That A is at A comma 0. So we have found the point A is on the x-axis at minus 7 comma 0. But you should understand something. We have taken arbitrarily point on the left side of x-axis. But unfortunately, we got it on the left side. There is a point here. minus 7 comma 0. Don't bother about it because this is a variable. Variable can take a negative value. We don't know because we did not know in the beginning. We took the point that side. It is a point on x-axis. Don't worry about it. That answer is minus 7 comma 0. So you can arbitrarily choose your point anywhere on x-axis, and finally when you get the answer, you realize that A is on the left side of origin actually. Okay, doesn't make much of a difference, no problem. Then there is another formula which we need to derive. Before that, of course, I just check if I have to work out this one. There's a 10th problem here. Find a relation between x and y such that the point x comma y is equidistant from the points 3 comma 6 and minus 3 comma 4. This is a simple problem where you just have to substitute and get some result. Okay. There are 2 points given to you. One is 3 comma 6 and another point is minus 3 comma 4. There is a point P whose coordinates are x and y, and P is equidistant from A and B. And you have to establish a relation between x and y. That's it. You just have to write a relation, not necessary to solve it. Can be solved, of course, because there are 2 variables here, x and y. There must be 2 hints for you, but only 1 hint is given. So you can't solve it, but you just have to write the relation between them. So I will take PA is equal to PB. This is the condition. This point must be equidistant from A and B. Or PA square is equal to PB square. Anyway, I put the root for the time being. Come on, x minus 3 whole square plus y minus 6 whole square. That is the distance PA. And go later to this distance PB. X minus 3, x plus 3 whole square and y minus 4 whole square. So this is the relation actually, but there is some simplification possible. The first step is squaring on both sides. Roots need not be written. Okay, I expand this one. X square minus 2 into x into 3, 6x plus 9. Similarly, a minus b whole square formula, y square minus 12y plus 36. Write this side also, x plus 3 whole square, x square plus 6x plus 9 and y minus 4 whole square, y square minus 8y plus 16 and x square plus y square, and the other side also x square plus y square. That's it. You bring all of them to one side. Let us see if we can get a linear equation. 6x will come to this side. Already there is a minus 6x. You get another minus 6x. You got minus 12y here. And let me write that minus 8y this side plus 8y. I can put all the numbers the other side, like 16 plus 9, 25. 36 plus 9, 45 will become minus 45 if it is written on the other side. That's it. So this is minus 12x and minus 4y. Minus 12 plus 8 minus 4y is equal to 25 minus 45 is minus 20. I can change the sign throughout so that it looks better. In fact, 4 also is a common factor in all of them. Come on, divide this by minus 4, 3x. Divide this by minus 4 plus y. Divide this by minus 4, 5. So this is the relation between x and y. Okay, and that is our exercise 7.1. And I go to derive the formula, section formula, and then we work out 7.2. Okay, and 7.3 also we have to determine the area of the triangle. Let's go to the section formula now. I just take see my x-axis and y-axis, number 1, and I take 2 points A and B whose coordinates are x1 y1 and x2 y2, and that line segment AB is divided by P in some ratio, say m1 is to m2. That's what we have to draw now. Okay, so this is my x-axis, y-axis. This is my x-axis, This is the Cartesian plane we are talking about. And there are 2 points here, A and B. A is at x1, y1 and B is at x2, y2. And here we have a point P. I can take anywhere I want. I can take here P. And let me say the coordinates of P are x comma y. Okay, so A x1 y1 and B x2 y2 are any 2 points in the Cartesian plane, and P is a point which divides this line segment in the ratio m1 is to m2. Means if this is m1, this will be m2. Okay, AP m1, PB m2. So the ratio is m1 is to m2. And what ratio is that? AP is to PB. AP is to PB is equal to m1 is to m2. Now I should find out this x and y in terms of x1, y1, x2, y2, m1, m2. Okay, that's the question. Very simple. And I draw the perpendiculars from all three, A, P and B onto x-axis. I just have to label them because this is my origin. P is already used. Okay, I just say L, M and N. And there are 2 more perpendiculars I have to draw, like from A here like this. I can say Q, there is no problem. And from P here I draw, let me say this is R. So now to prove my coordinates of that P, it's very easy for me. There are 2 triangles which are similar to each other. This is one triangle. Okay, this is one triangle. And this is another triangle. And those 2 triangles are similar to each other because they have the same angles they have got. And if I can, get the relation between the sides there, corresponding sides, my work is done. I want to know AQ. AQ. AQ is the same as LM. Okay, this LM. LM means OM minus OL. OM minus OL. OM is what? From here I came X and moved up Y. That's how I got this point. So OM is X. OM minus OL. So here it is X minus, what is OL? X coordinate X1, because X1 and Y1. Okay, to reach this point, X1 and Y1. So I just write X minus X1. Corresponding to this, I have this side, PR. I want to know what PR is all about. PR is the same as MN. This MN means ON minus OM. ON minus OM. And that will be ON is X2. OM is X. X2 minus X. So I got this side and I got this side. That part is done. But now I want to find out this height, PQ. PQ height I want. This PQ is PM minus QM. PM minus QM. PM height I know, Y. But QM is the same as AL. PM height I know, QM is same as AL. So PM height I know, Y. AL height I know, Y1. Y minus Y. And the last one, this I want, BR. BR is equal to, come on, BN minus RN. BN minus RN. BN height, no problem, I have Y2. But RN is the same as PM. So Bn minus Pm, and that is y2 minus y. That's it. Let me put the values I got here. This is x minus x1. This is x2 minus x. And this height is y2 minus y. And this height is, come on, tell me, y minus y1. That's what we have got here, y minus y1. Y minus y1. And if this is m1 and this is m2. Now compare the sides. That's it. Come on, x minus x1 by x2 minus x is equal to y minus y1 by y2 minus y is equal to m1 on m2. I repeat, m1 on m2 is equal to m1 on m2 is equal to x minus x1 by x2 minus x, x minus x1 by x2 minus x. Let us simplify this part first, of course. Now m2 into x, m2x, m2 into minus x1 minus m2 x1, cross multiplication. m1 into x2 is equal to m1 into x2 and m1 into minus x minus m1x. Bring this minus m1x this side. Already you have m2x here is equal to, this is m1x2, copy down as it is and take it to that side, plus m2x1. And therefore x is equal to, you take out x as a common factor here, m1 plus m2 will come, send it to that denominator, m1x2 plus m2x1 by m1 plus m2. Exactly in the same way you can get y also. Here you got x. Okay, this is the formula. We get y here, m1 y2 plus m2 y1 by m1 plus m2. So we have got the coordinates of this point P, x comma y. I just want to consolidate this and tell you, if a x1 y1 and b x2 y2 are the end points of the line segment, the coordinates of the point P which divides this line segment in the ratio m1 is to m2 are m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. I repeat this. You are given a line segment and the end points are given. If a x1 y1 and b x2 y2 are the end points of the line segment, the coordinates of the point P which divides this line segment in the ratio m1 is to m2 are m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. So we are getting the coordinates of P. The whole exercise is for that. Where is P? To determine P, of course, we have done the whole exercise using m1, m2, x1, y1, x2, y2. That's it. Okay. And to remember this one, of course, I draw the figure once again and mark the sides. Okay. And a bigger one I am going to draw to tell the difference. We drew y-axis and x-axis. Okay. And we were given the end points of a line segment. This is one end point, a x1 y1, and this end point is b x2 y2. And he is asking us, where is this P? Okay, for the time being you say x comma y, but he tells that P is dividing this line segment in the ratio m1 is to m2. That's it. You have to find out the coordinates of that point P which divides this line segment in the ratio m1 is to m2. What did we do actually? We drew the perpendiculars. We marked the perpendiculars as L, M and N. Okay. We drew two more perpendiculars here and here as well. Okay. And here we took Q and here we took R. These two are right angle triangles. Same angle you have here and here. And similarly, interior alternate angles, these two are also same. So these two triangles are similar to each other. That is what we were using, because this triangle, this is one triangle and this is another one. These two triangles are similar to each other. So we need to know the sides for the comparison sake, because corresponding sides are in proportion like. And here I said x minus x1. And this one is x2 minus x. And this height difference is y2 minus y. And this height difference is, this height is y and this height is y2. So you have y minus, sorry, this is x1, y1. Yeah, y minus y1. That's it. And ratio of these two sides, m1 is to m2, is the same as ratio of these two sides, is the same as ratio of these two sides. And if that can be understood, rest is only finding out x and y. That's it. Okay. Hope this is clear. And we do a few problems here based on this section formula. And that exercise is 7.2. Find the coordinates of the point which divides the join of, this is first problem, -1 comma 7 and 4 comma minus 3, and the ratio is 2 is to 3. So this is the ratio, m1 is to m2. The 2 points are x1, y1 and x2, y2. Okay, you need to find out that P, which divides this line segment in the ratio 2 is to 3. So we need to find out P. I write the formula m1 x2 plus m2 x1 by m1 plus m2. Similarly, m1 y2 plus m2 y1 by m1 plus m2. Simple substitution. Start. m1 is a 2 there. 2 into m1 into x2. 2 into 4 plus m2 is a 3. Okay. And x1 minus 1. 3 into minus 1 by m1 plus m2. Comma. Next one, this one. m1 into y2. 2 into minus 3. Plus m2 is 3, into y1, 7, by 2 plus 3. And that's it, we have got the answer. This is 8 minus 3, 5, 5 on 5, and that is 1. Minus 6 plus 21. 21 minus 6 is 15. 15 by 5. That will be 3. That's it. Therefore, P1 comma 3 is the required point. This is textbook problem number 4. And a line segment -3 comma 10. And another end point of the segment is 6 comma minus 8. And he is asking in which ratio this point P divides, and that P is -1 comma 6. In what ratio P divides this line segment AB? That is the question. So this is such an easy question. You can find out two distances and that's it. That will give you the ratio. Okay, and let us start. This distance I have to determine. AP is equal to -1 minus of -3, -1 plus 3 whole square plus 6 minus 10 whole square. And this is the first distance, root over this. Come on, 3 minus 1 is 2, 2 square is 4, and 6 minus 10 is minus 4, minus 4 squared 16, root over this root 20, and there is a small simplification possible. 20 can be written as 4 times 5, 4 has the root, so this can be written as root 4 into 5, so 2 root 5. Okay, now let us find out this distance PB is equal to under root 6 minus minus 1, 6 plus 1 whole square, minus 8 minus 6 whole square, that is equal to 7 square is 49. Okay, this is 6 plus 1 7, 7 square is 49, and minus 14 square 196, and this is 225. 225 can be written as 9 25s. Okay, am I right here? Yeah, 15 15s. I just write in a different way. I just want, yeah, 9 25. I can straight away write 15. Okay, 15 15s. Once again, let us just check. This is 245. 230 plus 15, 245, and 245 is 49 fives, and that will be 7 root 5. That's clear now. So AP is to PB is 2 root 5 is to 7 root 5, and the ratio is 2 is to 7. Okay, and we take up another problem, a similar problem here. Find the ratio in which the line segment A1 comma minus 5. See, this is an interesting problem. A minus 1 comma 5. Okay, let me take this as fifth problem. Textbook fifth, textbook 4. Okay, A minus 1 comma 5 and B minus 4 comma 5, and this is divided by some x-axis. Okay, let us say x-axis P. P is on x-axis, that is what you are given. If it is an x-axis, the y-coordinate will be 0. Okay, so line segment AB minus 1 comma minus 5. Okay, 1 comma minus 5, 1 comma minus 5, and minus 4 comma 5. It is divided by x-axis. Okay, and the point, corresponding point is P, and because this is a point on x-axis, I have taken y coordinate 0. Let us take now how we get this P. Ratio is not given to you. Let us take M1 is to M2, which you need to find out. Come on. Let the ratio be M1 is to M2. Let the ratio AP is to PB is equal to M1 is to M2. How do you get now? How do you get P? P is M1 into X2, M1 into minus 4 plus M1 into X2, M2 into X1. M2 into 1 by M1 plus M2, comma, come on, M1 into Y2, M1 into 5, M2 into Y1, M2 into minus 5 by M1 plus M2. This is what P is all about. But remember, the y coordinate of P is 0. Means this must be 0. Okay, if this is 0, let us find out M1 is to M2. If this is 0, numerator must be 0. Okay, I just take a little space here. Come on, 5M1 minus 5M2 must be 0, because the numerator must be 0, because this is going to be 0, because this is a point on x-axis, y coordinate must be 0. So 5m1 is equal to 5m2, and m1 on m2 is 1:1. That's it. So P divides AB in the ratio 1:1. So that is how we work out that one. And I go to 8th problem. This exercise 7.2. Find the coordinates of the point A, where AB is the diameter of the circle, whose center is 2, -3 and B is 1, 4. This is an easy problem. You have a circle where AB is the diameter and B is 1, 4. Okay, and center is 2, -3. This is an easy one, like center is 2, -3, and find A. That's it. Okay, AB is the diameter of the circle, B is given to you, and the center is given to you. You must be knowing one thing, that AO is to OB is 1:1. Okay, so if this is 1, this must be 1, because this is the center, this is the diameter, radius, and this is also radius actually. So you know the midpoint, and one end you know, the other end you have to find out. That's it. And if you say this is A, B, your work is done, because this is the midpoint. Midpoint, how do you find out? x1 plus x2 by 2 and y1 plus y2 by 2. So we write like this: let A be A, B. Okay, O is the midpoint. O is the midpoint, and come on, O is A plus 1 by 2, comma B plus 4 by 2. So this is the formula for the midpoint, but midpoint is given. Come on, A plus 1 by 2 is equal to 2. A plus 1 is 4 and A equals 3. Come on, similarly, B plus 4 by 2, y coordinate of O you are given as -3, and B plus 4 is equal to 2 times -3 is -6, and B equals -10. So where is A now? 3, -10. I repeat this point, actually O is the midpoint of AB, and one extreme you have to find out of the diameter, and one extreme is given, you have the center. So if you say this is A, B, A plus 1 by 2 is equal to 2. B plus 4 by 2 is equal to -3. Okay, that's how we got that A and B. And you are given 4 vertices here of a rhombus. You need to determine the area of that rhombus. This is a cute problem, of course. This is 10th problem. And this one is textbook 7. We are looking at this one. You are given a rhombus. Okay. And you should know that all the 4 vertices are always given in order. 3, 0. Okay. This is 4, 5. And this is -1, 4. And finally you have got -2, -1. And let us label the points as A, B, C, D and find the area of the rhombus. And how do we go about? We find out this diagonal and this diagonal, and half the product of the diagonals is the area of the rhombus. So I need to find out AC. Distance AC is equal to, come on, 3 minus -1, 3 plus 1 whole square, plus 0 minus 4 whole square. And If you simplify, this is 4 square 16 minus 4 square also is plus 16 root over 32. Okay, this is 16 twos. I have square root of 16, 4 root 2. Now I need to find out this distance BD. This I found out, D1 and D2. This diagonal I have to find out, BD. Tell me now how you can do this one under root. Come on, 4 minus minus 2, or you can say minus 2 minus 4. No problem. 4 minus minus 2 is 4 plus 2 whole square. And the next one is 5 minus minus 1, 5 plus 1 whole square. So this is 6 squared, and this is also 6 squared, and root over 72. 72 is 36 twos. 36 has got a square root, 6 root 2. 36 twos. 36 square root of 36 is 6 root 2. Now I just take this space to determine the area of the rhombus. A is equal to half d1 d2, half, and one diagonal I got here as 4 root 2, and another diagonal I got as 6 root 2. And the answer is 24 square units. Root 2 times root 2 is a 2, and that 2 gets cancelled with this 2. So 6 times 4 is 24 is the answer. So we have determined the area of the rhombus given all the 4 vertices, and that is our exercise 7.2. And now I have another formula, of course, to be derived. I do this, and later we have few problems in exercise 7.3, okay, where you need to find out the area of the triangle. Let me start. And this is an interesting proof, but it takes a little time for you. Formula to find out the area of a triangle. Okay, our work is now this one, formula to find the area of a triangle. Okay, and let us start working out. You are given a triangle. That means the 3 vertices are known to you, x1, y1, x2, y2 and x3, y3. We start there. Okay, now this is my y-axis, this is my x-axis, and I have a triangle like this. This is the triangle, and I take my vertices A, B and C, arbitrarily chosen. This is A, x1, y1, B, x2, y2, and C is x3, y3. 3 vertices are given to me. What is that I should do now? I want to find the area of this triangle. Fine. You see how I am doing this. I draw perpendiculars from all the 3 vertices to x-axis. That's the first thing done. Now I want to show you 3 trapezia. Okay, and if you can identify them, you see carefully, like this is one trapezium, and I label it. Wait for a while, because I mark the feet of the perpendiculars as L, M and N. Now what is the trapezium that is labeled A, B, L, M? That is one trapezium we have identified. There is another trapezium which we are trying to identify. This is the second one. Can you name this one? This trapezium I am shading now. Okay, the trapezium now I shaded is A, M, N, C. That is another trapezium I shaded. I add this trapezium and this trapezium, but from that I take away this trapezium. That trapezium I take away. Which trapezium is subtracted? Can you tell me? Like, B, L, N, C is subtracted. And let us do that now. Trapezium, area of trapezium. What is the first trapezium? A, B, L, M. Number 1. Area of trapezium. Come on. A, M, N, C. A, M, N, C. We are adding. This trapezium plus this trapezium we are adding. Taking away this trapezium. What is that we are subtracting? Can you tell me? Area of trapezium. Come on. B, L, N, C. B, L, N, C. Okay. So, if you want to find the area of this first trapezium, okay, half sum of the parallel sides multiplied by distance between them. This height is y2. This height is y1. And distance between them is a difference of x coordinates, x1 minus x2. How do you find out the area of this trapezium? Area of this trapezium. This height is y1 because this is one of the parallel sides. Another parallel side is this y3. And distance between the parallel sides, these two, is x3 because I came x3 like this to reach this point. And till here it is x1, x3 minus x1. Okay. Now we can start the work. First, this trapezium. Sum of the parallel sides and distance between them. Come on, sum of the parallel sides is y1 plus y2 multiplied by distance between them, x1 minus x2. This is done. Come on, this trapezium we are talking about, this trapezium. Sum of the parallel sides, y1 plus y3, half y1 plus y3 times distance between the parallel sides from m to n, mn, x3 minus x1. And finally, I have to subtract the area of B, L, N, C. That's what I have to subtract. B, L, N, C. Sum of the parallel sides. This height is y2, this height is y3. y2 plus y3 times distance between these two. I can do one thing. I can add this and this. x3 minus x2 will come because minus x1 plus x1 will go x3 minus x2. That's it. Okay. And I can put a mod here. Area of the triangle is this one. Area of the triangle. Now, if I simplify this one, I just straight away write the answer. You write x, y, y. Again you write x, y, y. Again you write x, y, y. Close it. Now 1, 2, 3. Start with 2. 2, 3, 1. Start with 3. 3, 1, 2. So this is how you get the formula. And the figure I am going to show once again to give you a little clarity. Okay. See the figure carefully how I am doing. I leave it here. And okay. This is the triangle we are given, whose area you need to find out. We named it as ABC. Okay. Same figure I am drawing here once again. We drew the perpendiculars like this. Straight you have to come down. Label it as L. M, and here it is N. Now, two trapezia you must add and subtract one of them. Okay, the first trapezium is this one. First trapezium is that. Name this one A, B, L, M. That's the first trapezium. You have to add another trapezium. Okay, that trapezium is this one, because this is another trapezium. Can you name this trapezium here? A, M, N, C. So this trapezium and this trapezium we added, and we are subtracting the area of one of them. Another trapezium we are subtracting, and whatever I am subtracting, I erase that actually. Like this is being subtracted. And if you can understand what is subtracted, you know that you got a triangle. There's a triangle we got. So we added the areas of two rectangles and we subtracted this one. And that is how we got this, okay, area of the triangle. And the formula, how do you remember? Half modulus x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This is a continuation of our coordinate geometry, and today we are going to talk about the area of a triangle considered in the Cartesian plane whose vertices are a x1 y1, b x2 y2 and c x3 y3. Okay, let us try to draw the figure and understand the formula so that we can start applying that, of course, in the problems we have in exercise 7.3. Okay, so here you have y-axis and you have x-axis, and you have a triangle whose vertices are given, and this is a x1 y1, and this is b x2 y2, and this vertex is c x3 y3. And we need to find out the area of this triangle, and we derived that formula. I am just writing the formula now. Area of the triangle is equal to, triangle ABC is equal to half mod, you write down xyy plus xyy plus xyy. This is a cyclic expression. You write down first. Then you write 1, 2, 3 in the cyclic order. 1, 2, 3, 2, 3, 1. Don't go back in the same direction. 3, 1, 2. 1, 2, 3. Come on. 2, 3, 1. And 3, 1, 2. And this is how we remember the area of a triangle. Okay. x1 times y2 minus y3. Plus x2 times y3 minus y1 and plus x3 times y1 minus y2. This is how we remember the area of the triangle given three vertices a x1 y1, b x2 y2 and c x3 y3. I want to give you a few hints about some more problems, of course, we have there in the exercise. The next one, say you are given a quadrilateral. Okay. When you are given a quadrilateral, when you, like you are supposed to find the area of that one. Let me take this quadrilateral as PQRS. So you need to find the area of this quadrilateral. Okay, 4 vertices are there because it's a quadrilateral. But we know only the area of a triangle. Okay, when 3 vertices are given, you can determine the area of the triangle. But what should we do now is, you just divide the quadrilateral into 2 parts, 2 triangles, by drawing one of the diagonals, either this PR or you can draw QS also. Now, using 3 vertices, you find the area of this triangle, and using 3 vertices here, you find the area of this triangle. And later, if you add these 2, you get the area of the quadrilateral. So you don't need a separate formula for that with the vertices x1, y1, x2, y2, x3, y3 and x4, y4. Not necessary to have a different formula and all that. For the time being in this class, what is usually done is that you divide that given quadrilateral into two triangles by drawing a diagonal, and as you get two triangles, of course you can find that area of each of them separately, and you can add them. This is one problem, of course, which we need to consider seriously. Another problem, of course, you have there is, suppose you have a triangle. Okay, this triangle is, say, XYG. Okay, and this is a triangle you are given. You mark the midpoints of the sides of this triangle. Identify the midpoints of the sides of this triangle. So something like, I just mark the midpoints of each of the sides. Of course, you got, let me say this triangle is PQR. Okay, and there is one triangle formed inside by joining the midpoints of the sides of the given triangle in order. There is a triangle formed. But see, you learned in geometry one important feature. The figure formed by joining the midpoints of the sides of a triangle is 1/4 of the original triangle. Okay, in fact, all these four triangles are congruent. They're one and the same. They're exactly same. And the triangle, what you identify, triangle PQR's area is 1/4 the area of the given triangle, because these are four such pieces, 1, 2, 3, 4. And one of them you're talking about. And therefore, you should understand like this, triangle PQR's area is 1/4 the area of triangle XYZ. And this is an important principle while doing some of the problems, of course. I repeat this once again. You are given a triangle and you joined the midpoints of the sides of this triangle in order. You found another triangle, of course, that's triangle PQR. And triangle PQR's area is 1/4 or 1/4 the area of the given triangle. If you can understand that, of course, and that's very interesting. And I just want to spend a little time here to tell you why is it 1/4. Okay, and see, the theorem goes like this. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and half in its size. And I apply that theorem here. So if this side is 2x, say I write here x small x, and this will be x, because we are joining two midpoints, PQ. And if this is 2x, this will be x. And similarly, if this is 2y, and this will be y, half of that. And these two are parallel also. Okay, these two are parallel to each other also. And exactly in the same way, if this side is ZZ, and this will be Z. And look at all the four triangles you've got. Every triangle there has got the same sides, X, Y, and Z. Okay, so if you watch it carefully, you take this triangle PQR, X, Y, Z. This one you take X, Y, Z. This one you take X, Y, Z. And this one also, of course, X, Y, Z. So all the four triangles, they've got the same sides. Exactly the same sides they are formed by that. Therefore, all four of them are congruent, and the area of the triangle, of course, you are considering in the middle is 1/4 of the given triangle. Okay, that's as simple as that. Let us start doing a few problems so that like it. And my first problem is, you are given three vertices and you need to find out the area of that. 2, 3, -1, 0, and the last vertex is 2, -4. 2, -4. So this is a triangle ABC, okay, for our consideration. And I want to give you a small hint before I go there. These 3 points, if they are lying on a line, you don't get a triangle. The points must be non-collinear. They should not be in a line. By any chance, if all the 3 points, of course, they belong to the same line, the area of the triangle, of course, you get it, is 0. When the area is 0, the point is that the lines are collinear. I mean the points are collinear. They lie on the same line. There is no triangle formed actually. And that's the only point you have to consider. In all cases, you get some area which is positive, and let us look for that. And by any chance, if your answer is 0, so you should understand the vertices you have taken, of course, they don't form a triangle, and the points are lying on the same line. Okay, fine. Now, area of triangle ABC, I write the formula half mod x1 y2 minus x1 times y2 minus y3 plus x2 times y3 minus y1 and plus x3 times y1 minus y2. But order you should not miss, of course. You can take in the counterclockwise direction or clockwise direction, but maintain the same direction. 1, 2, 3. If you want to say, yeah, 2, 3, 1 and 3, 1, 2. Okay, that it should not miss. Just a simple substitution. x1, y1, x2, y2, x3, y3. Half mod x1 is 2. y2 minus y3. 0 minus minus 4. Plus x2. x2 is minus 1. Minus 1. y3 minus y1. y3 is minus 4. Minus y1 is 3. And lastly, x3 is 2. y1 minus y2. 3 minus 0. That's it. What is it going to give me? 2 times 4. Minus 1 times minus 7. Plus 7. And 2 times 3 is a 6. And 8 plus 7 is 15. 15 plus 6 is 21. And half of 21, of course. And you just simply write square units because it's the area. So this is how we work out. Same thing goes for even if you have a quadrilateral. Find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are given, and find the ratio of the area to the area of the given triangle. So here there are two things, of course. You are given a triangle, you mark the vertices, and you also need to find out the midpoints of the sides. Midpoint formula is easy to remember, of course. x1 plus x2 by 2 comma y1 plus y2 by 2. Okay, it's average of the x coordinates and average of the y coordinates. I'm going to do that problem, of course. I can do here. Now this is a triangle given to me. I just draw a line. This is over and we are here now. This is a triangle. And here I take it as PQR, and the vertices given are 0 comma minus 1, and the second is 2 comma 1, and the third one is 0 comma 3. So you are given this triangle, and you need to find out the area of the triangle formed by the joining the midpoints of the sides of this triangle. So how do I get the midpoint of this one? I'm writing, of course, 0 plus 2, 2, and take half of that. Okay, and that will be 1. And this is minus 1 and this is 1. If you add them, it is 0. Half of that is 0. So I got the midpoint there. Anyway, I am going to do it there, but still, of course, this is, let us say, y. How do I get this? This is 2 plus 0, 2. Half of that is 1. And 1 plus 3 is 4. Half of that is 2. So I got another midpoint of, say, QR. I want the midpoint of PR. Okay, 0 plus 0 is 0 and half of that is 0. Okay, I am going to get my z here. Like, come on, next one. Minus 1 and plus 3, it is 2. Half of that is 1. So I just write this part here. My P is 0 comma minus 1, and Q is 2 comma 1, and my R is 0 comma 3. And I try to find out the area of this PQR, triangle PQR, and just mention here it is area and half. I am substituting here x1 times y2 minus y3, 1 minus 3, plus x2 times y3 minus y1, 3 minus minus 1, 3 plus 1 plus x3 times y1 minus y2 minus 1 minus 1. We are done with this, and half of 0 times something is 0, 2 times 4 is 8, and 0 times something is 0, and half of this 8 is 4 square units. And now my next part is I need to find out the area of this xyz. Okay, and those vertices are x is 1 comma 0, y is 1 comma 2, and z is 0 comma 1. And we need to determine the area of triangle xyz. Start half of x1 times y2 minus y1. It's y2 minus y, x1 times y2 minus y3, 2 minus 1. Next, x2 times y3 minus y1, 1 minus 0, plus x3 times y1 minus y2, 0 minus 2. So here half of 1 time this 1 is 1, 1 time this 1 is 1, and this is 0 times something is 0, and the answer is half of this 2 is 1 square units. We have got a very interesting result, of course, to notice. If the area of the given triangle is 4 and the area of the triangle formed by joining the midpoints of the sides of the given triangle is only 1. This is 4, this is 1. It is 1/4. And therefore, we write the conclusion here, area of triangle XYZ is 1/4 of the area of triangle PQR. So if the given triangle has got the area of 4 square units, of course, the area of the triangle formed by joining the midpoints, we got only 1. That is 4, this is 1, this is 1/4. That's what you have to understand like. And thank you so much, and that is the analytical geometry we have got. We have few things, and I just want to consolidate what we have learnt. The first of them, we learnt the distance formula, and the second one we learnt the section formula, and the third one we learnt, of course, the area of the triangle formed, of course, when the vertices are given. And using these three formulae, you can work out all the problems given in the exercises, and that is our analytical geometry. Thank you.